So we want to look at the binomial identity. If K and R are integers such that zero is less or equal to R and R is less or equal to K, prove that KR is equal to K plus 1 choose R minus K R minus 1. Okay, so I want to get the proof of this. So you start with one side. So let's start with the right-hand side and see if we'll be able to get the left-hand side. So our right-hand side, K plus 1 choose R minus K choose R minus 1. So this is equal to, for K plus 1, we define it the way we define N choose R factorial. So you say K plus 1 factorial over R factorial, K plus 1 minus R factorial. So we are subtracting K factorial over R minus 1 factorial, K minus R. So it's going to be plus 1 factorial because negative R minus 1 is the same as negative R plus 1. So we write it that way. Okay. So now, these are two fractions. We need to get the common denominator. So before I can put down the common denominator, you need to recall that when you define R factorial, we say it is R minus 1 factorial. We can write it in that way. Okay. So in factorials, I can keep multiplying going down. For as long as when I decide to end, I put the factorial, then everything is okay. Okay. So I could have chosen to say R minus 1, R minus 2 factorial. But I've chosen this for a specific reason. If you look at this part, it's got R minus 1 factorial. If you look at this part, it's got R factorial, implying that if I write R factorial in the form R minus 1 factorial, then the common denominator between this one and this one is the R factorial. So I'm going to write R factorial down, and then these other two, they are just the same. So I have K minus R plus 1 factorial. So when you divide this one in the whole denominator down, this is just the same thing. So we just get a 1 multiplied by the numerator. It comes out as K plus 1 factorial minus, so I'll put the K factorial there. And then when you divide R minus 1 factorial over R minus 1 factorial, so we just get R. So I'm saying R minus 1 factorial to represent R factorial, which we have in the denominator here. So we get just R. Okay. So now, here again, we have a K plus 1. K plus 1 factorial can also be reduced the same way we reduce R factorial, where we say K plus 1, and then when you subtract a 1 from K plus 1, you just get K factorial. So I've lowered it a bit using multiplication, and then when I decide to end, I put a factorial. So I have K plus 1, I subtract a 1, it becomes K, and then I put a factorial. So I have the same thing. So now where there is K plus 1 factorial, I'm going to write K plus 1 multiplied by K factorial. So we have K plus 1 multiplied by K factorial, then minus K factorial, multiplied by r. So we have done this so that we can factor out the k factorial. So the down part also, let us also lower it by 1. So it's going to be k minus r plus 1. And then when I subtract 1, it becomes k minus r factorial. So k factorial is common there. And so we have k plus 1 minus r. And down here, we have r factorial. We have k. So I can write the denominator if I want, or just the same way. This and then k minus r factorial. And this is the same as this part. Can take away this part. So we have k factorial over r factorial, k minus r factorial. So in case you are not able to see that we have reached the left-hand side identity, you can pick the left-hand side and just try to see if how it gets defined. This is just the same as k factorial, r factorial, and k minus r factorial, which is what we have here. So we just say this is the same as k r factorial, which is the left-hand side. So what does that mean? It means that we are done. Hence proved. I hope you like it. Please don't forget to subscribe and like the channel so that you get notifications every time I post. Thank you.